Let us see how to write a function program to find the factorial of a number. So you can see that we have included the standard input-output header file for printf and scanf, and the function prototype of the factorial will be fact, which takes an integer arguments and it returns a long integer value. So in the main, I have declared one integer variable n and a long integer for storing the result. So I will print a message, enter the value of n, and I am reading the value of n by scanf %d ampersand n. And the factorial is called by passing the n as an argument, and the written value will be stored into the res. And printing the factorial of n is result. So in the function fact, you can observe, so one long integer f which is initialized to 1 and one more variable I is declared as an integer. So for I is equal to 1, I less than or equal to x, I plus plus f is equal to f star I. That is factorial of n is 1 into 2 into 3 into up to n, which is computed by using the for loop and returning the value of f to the calling function, to the called function. So now if you run it, we can see that if I enter the value of n as 5, you can observe that the factorial of 5 is 120. And if you run with the value of n as 10, you can observe that the factorial of 10 is 3362880. Now let us see one more function program to print the prime numbers between a set of values. Now here I will be making use of is prime function to verify whether the argument which is passed is a prime or not. So in the main program, I have declared three variables a, b for lower limit, upper limit, and for the indexing I am using the variable I. So I will be reading the values of lower limit and upper limit, and I am printing the message prime numbers between the lower limit and upper limit are. And you can observe here for I equals to a, because I need to print the prime numbers between a to b. So I varies from a and I less than or equal to b, I plus plus, I will be calling is prime function. So this is prime function will be taking the argument I, which is every number which is to be verified whether it is prime or not as an argument, and this is prime returns 1 whenever the argument is a prime number. So if is prime of I, will check the value of I for prime, and if it is greater than 0, then it is printing that value of I, which indicates that it is a prime number. So this will be repeated for all the values between the range from a to b. You can observe in the is function I have declared I and n is passed as an argument. So I have a loop I varies from 2 to n by 2, I plus plus. So if n mod I is equal to 0, it means if n is divisible by any of the numbers from 2 to n by 2, which indicates that it has some divisors, which indicates it's not a prime number. So at that point we are returning 0. If this condition is not satisfied for all the values from 2 to n by 2, then the value of 1 will be returned to the calling function, indicating it is a prime number. So let us see how to run it and see for some outputs. So suppose I enter the lower limit as 10 and upper limit as 100. You can see that the output will be printing prime numbers between 10 and 100 are 11, 13, 17, 19, 23 until 97. Thank you.